So, let me ask you a question. It sounds a little philosophical, maybe even a bit egotistical, but are you the center of the universe? Now, what if I told you that's not just a thought experiment, it's a serious question in physics? We're going to dive into this because the answer is going to completely rewire how you see your place in the cosmos.
I mean, just think about it. When you look up at the night sky, every single direction we point our telescopes, we see galaxies rushing away from us. And the farther away they are, the faster they're going. It creates this perfect sphere of observation with you right now smack dab in the absolute geometric center. No matter where you look, up, down, left, right, the edge of what we can see is the same distance away. The observational evidence is, well, it's undeniable. And yet, for basically all of modern science, we've been operating on the idea that we're not special, that there's no privileged spot in the universe. So what gives? How can we be at the center of everything we see and at the exact same time not be at the center at all? That is the cosmic mystery we are going to solve right now.
Okay, so the key to cracking this whole paradox, it starts by fixing the single biggest misconception in all of cosmology. And it's funny because it's right there in the name, the Big Bang.
When you hear Big Bang, your brain immediately pictures a bomb, right? Something going off at a single point in an empty room? But that is completely, fundamentally wrong. The Big Bang wasn't an explosion in space, it was the expansion of space. It wasn't some event that happened way over there. It happened everywhere, at once. That one little word difference, in versus of, that changes everything. Yeah, let that one sink in for a second. The Big Bang happened right where you are sitting. It happened where the moon is. It happened at the location of the most distant thing we can possibly see. Every single point in our universe today was present at that initial, hot, dense state. There was no center point, because every point was the center point.
You know, it's kind of funny, we use these analogies to try and explain this, but they often end up reinforcing the wrong idea. Take the raisin bread. It's great for showing how the dough of space expands and carries the raisin galaxies apart. Awesome. But a loaf of bread has a center, and it has a crust, an edge, and the universe doesn't. That's a fatal flaw. The expanding balloon is a little better, right? On its two-dimensional surface, no single point is the center. But it's expanding into something, and it has a clear center on the inside. So you have to mentally throw away the bad parts of these analogies to really get it.
So if there's no center and no edge, what are the rules of the road? Well, modern cosmology is built on this one really foundational assumption. It's a hypothesis we can actually test, and it's called the cosmological principle. This whole principle really rests on two main pillars. The first is homogeneity. This is just a fancy way of saying that if you zoom out far enough, the universe is basically the same everywhere. There aren't any special locations, no cosmic capital city, and no empty borderlands. On average, any huge chunk of the universe looks pretty much like any other huge chunk. And the second pillar is isotropy. This means from your vantage point, or any vantage point, the universe looks the same in every single direction you look. There's no special axis of the universe or some preferred direction in the cosmos. It's the same beautiful cosmic tapestry no matter which way you turn your head. Now you might be thinking, okay, that's a nice idea, but where's the proof? Well, this isn't just a philosophical idea. It makes a testable prediction. If the universe has no center and it's the same everywhere, it should look the same in all directions. And guess what? We have the ultimate proof, the afterglow of the Big Bang itself. It's called the cosmic microwave background. And this is just incredible. When our telescopes measure the temperature of this ancient light from every single direction in the sky, it is stunningly, almost unbelievably uniform. The tiny temperature ripples are minuscule. We're talking just 1 part in 100,000. The universe doesn't have a hot side and a cold side. It is isotropic to a staggering degree of precision. This is the bedrock observation that tells us the no-center model has to be right. Okay, so if the universe has no center, let's get back to our original problem. Why on earth does it look like we're in one? This is where it all comes together. This is where we solve the paradox by understanding the difference between the universe and your universe. The logic is actually pretty straightforward. The universe is about 13.7 billion years old. Light travels at a fixed, finite speed. Put those two things together, and it means there's a fundamental limit to how far we can see. A horizon. Light from anything beyond that cosmic horizon simply hasn't had enough time in the history of the universe to reach us yet. This creates your own personal bubble of information, called your observable universe. And here's the absolute key. That boundary isn't a wall out there in space, it's a wall in time. You're seeing the light from 13.7 billion years in the past.
So, by definition, you are at the dead center of everything you can possibly see. Your observation was 100% correct. The light from that 13.7 billion-year-old boundary has traveled an equal distance from every direction to reach your eyes, forming a perfect sphere of perception right around you.
And this is the beautiful part. So is everyone else. An alien astronomer in a galaxy 10 billion light-years from here is also at the dead center of their observable universe. They see their own 13.7 billion-year-old sphere of light surrounding them exactly like you do.
So you see, the very fact that everyone gets the same "I'm the center" experience is the ultimate proof that no one truly is. Your seemingly special, privileged view of the cosmos is actually the most common, universal view there is. The paradox just melts away. Your central position is real, but it isn't unique.
But you know how it is in science? A really good solution often just reveals an even deeper, more fascinating problem. And the very uniformity of that cosmic microwave background, the key piece of evidence we just used to solve our mystery, it creates a brand new paradox.
Think about this for a second. We look at the CMB light from one side of the sky, and we look at the light from the complete opposite side. When that light was first emitted, those 2 points in space were already billions of light years apart. And since nothing can travel faster than light, there was never enough time for heat or any information to travel between them. They were never in contact. So how did they know to be the exact same temperature, down to 1 part in 100,000? It's impossible. It's like finding 2 random people on opposite sides of the Earth who've never met, but their body temperatures match to 1,000th of a degree. It just shouldn't happen.
The leading and totally mind-bending solution to this is a theory called cosmic inflation. It suggests that in the very first, tiniest fraction of a second after the Big Bang, the universe went through this period of insane hyper-expansion. The fabric of space itself expanded way faster than the speed of light, which, believe it or not, general relativity allows. Before this happened, the entire region that would one day become our observable universe was a microscopic, connected patch that had plenty of time to even out its temperature. Then inflation hit and stretched that tiny, smooth patch to absolutely cosmic size, locking in that uniformity forever.
And that leaves us with one final awe-inspiring question. If our solution is right, it means that our entire vast observable universe is just one inflated bubble that was once smaller than an atom. So, what else is out there, beyond our horizon? Is it just more of the same, stretching out forever? Or could there be other bubbles, other universes born from that same inflationary process? You are the center of your universe, but you may also be just a tiny, tiny part of something far, far grander than we can even imagine.